In this video, I will explain how to use Newton's method to approximate the root of a function. So let's jump right into an example. This says, use Newton's method to find the root of f of x equals x cubed plus 2x minus 5. Now, when we say we want to find the root of a function, it just means we want to find the x value that makes the function equal to 0. So if we were to plot this function, here's what it would look like. So for this particular function, it turns out that there's only one x value where the function is actually equal to 0, and that's an x value of 1.3283. So when we plug this value in for the x's in this equation, f of x turns out to be 0. So it turns out that Newton's method is a way to actually find this x value, and here's how this method works. The first step is that we need to pick a few x values to plug into this function. So one common choice is the value 0. So let's plug in a value of x equals 0 into this function. So f of 0, that would be equal to 0 cubed plus 2 times 0 minus 5. And that's equal to negative 5. Now let's try a value of x equals 1. So f of 1 would be equal to 1 cubed plus 2 times 1 minus 5. So this is 1 plus 2, which is 3, minus 5 is negative 2. And then let's try another value. So let's say x equals 2. When we plug in a 2, we get f of 2 is equal to 2 cubed plus 2 times 2 minus 5, which is equal to 8 plus 4, that's 12, minus 5 is 7. Now, when we're plugging in these different x values, what we're looking for is a sign change in the output of f of x. So for example, we can see as we go from x is equal to 1 to x is equal to 2, the sign of the output changes from a negative value to a positive value. So because f of x is a continuous function, if we're switching from a negative value to a positive value, it means that we must be crossing the value 0 at some point. So what that means is that a root must lie between x equals 1 and x equals 2. So now what we do is we just pick a value between 1 and 2 to plug in for x into the equation. So let's just pick the value 1.5. Since this is our very first guess at what the root might be, we're going to call this x sub 1. Now, Newton's method uses the following formula to find the next x value. So to find x sub 2, here's what we do. Newton's formula uses x sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. So using this formula, we would say that x2 will be equal to x1 minus f of x1 divided by f prime of x1. So this f prime right here, this is the derivative of our original function. So if we consider this function, the first derivative, f prime of x, would be equal to 3x squared plus 2. So let's go ahead and start plugging in some values. So for x1, we said we'll use a value of 1.5. So we have 1.5 minus f of 1.5 divided by f prime of 1.5. So then we get 1.5 minus f of 1.5. That means plug in an x value of 1.5 into this function. So that would be 1.5 cubed plus 2 times 1.5 minus 5. Then we divide that by, we're going to plug in 1.5 into f prime. So we found f prime to be this equation. So that would be 3 times 1.5 squared plus 2. So this numerator value turns out to be 1.375. And this denominator value turns out to be 8.75. So I'm going to go ahead and erase this and make a little bit of room over here. So for x2, we have 1.5 minus 1.375 over 8.75. So this turns out to be 1.5 minus 0.1571. And that comes out to 1.3429. So our value for x2 is 1.3429. So this is our next best guess of what the root of the equation is. So our first guess was 1.5. Now our second guess is 1.3429. Now to find x sub 3, we can use the following equation. X sub 2 minus f of x sub 2 divided by f prime of x sub 2. We're just repeating this process over and over again using these new x values. So here's what we get when we do that. And I'll erase a little bit of this down here. So we get x sub 3 is going to be equal to, remember for x sub 2 we're plugging in this value right here. So we have 1.3429 minus f of 1.3429 divided by f prime of 1.3429. So here's what we get. X sub 3 is equal to 1.3429 minus, when you plug in 1.3429 for x into this original f of x equation, the result is 0.1076. And then when you plug in 1.3429 into this f prime equation for x, you get 7.4101. So for x3, we end up with 1.3429 minus this quantity turns out to be 0.0145. So our answer comes out to about 1.3283. So this is our value for x3. Now we can see x1 was a value of 1.5, x2 was 1.3429, and x3 is 1.3283. So we can see that the differences in each iteration are differences between the x value are getting smaller and smaller and smaller. So because these differences are getting so small, it means that we're likely very close to the true root of this equation. And you'll find that the more iterations that you do of Newton's method, the closer and closer that you will get to the true root of the function.